Blessings to you all. Welcome to our revision class, grade 12 mathematics. In this particular section, we're just going through different types of questions on Euclidean geometry with special attention on proportionality and similarity. So these are examination questions definitely. So in our examinations, we expect to see something like this. Please don't memorize the questions. They're just meant to give us an idea on how some of the questions may be approached. Important when you are dealing with geometry is that like in this case, we want to prove that the expression given here, which is 2dc squared is equal to OD squared plus OD times OA. Now, one of the things that some learners will do is they look at this expression first, then they take their time pondering on this expression. Now, this is like 5, 6, 7 marks. Now, the moment you look at it, it will create a situation where your mind can get worried. They're like, yo, how am I gonna reach there? So it will cause you to operate from fear or get a mental block. The question will then become difficult. You have a higher chance of getting it wrong. So what we need to do in a geometry question is every geometry question that we are given comes with the hints that indicate the particular theorems which are applicable in that question. Now, the hints that we have discussed so far in other videos, if you are given the center of the center is an indication of theorems. We know that angle at center is twice the angle at circumference. If the center is connected to a tangent, then we know radius is perpendicular to tangent. Angle at center is twice the angle at circumference. We need to know all those things. Then another keyword in geometry is tangent. The tan chord theorem, two tangents are equal from where they touch to where they touch the circle, and radius perpendicular to tangent. Then the cyclic quadrilateral, 4 points touching the circumference of the circle. If the diagonals of the cyclic quadrilateral are connected, then we can have angles in some segment as well. And other relationships that are important, like parallel lines, perpendicular lines. All of those are hints that are used, that are in our examination questions that can help us determine which particular theorems to apply in answering which particular questions. Now let's have a look at this one here. We see that we are given the center of the circle. That's very important for us. Then apart from the center of the circle, we are given the point C, which is the midpoint according to the description given. Now, using that information, we can be able to notice that angle B and angle D are equal to each other because line OB and line OD are the radii. The radius is the same from the center to any part of the circle. So that means the triangle OBD is an isosceles triangle in which angle B and angle D are equal to each other. Then we are given the angle C, which is a line, which is a 90-degree angle. Now it's not given that it's 90-degree here, but we are told that the chord BC is bisected. So if the chord is bisected, then we have line from center bisecting a chord, or line from center drawn to midpoint of chord is perpendicular to the chord. So that makes the angle C2 equal to 90 degrees. Now, if you are given, then also we have got this relationship here, which probably is going to be part of our solution as we solve these problems. Now, if you are given an expression like this one, we want to prove this whole relationship here. This comes from similar triangles. You must identify the triangles from which these lines are coming and prove that those two triangles are similar to each other. Once we prove that the triangles are similar to each other, then we can express the sides of the triangles in proportion or as fractions, and then be able to create this expression by cross multiplication. So here in this diagram, we identified our two triangles that are similar to each other. And in this case, it's triangle DCO and triangle DAB. I have identified these triangles by analyzing the lines which are in the expression that we want to prove. Now, in the two triangles, they are sharing triangle D. I like these triangles that have a shared angle because it makes it easier. They are sharing angle D, so D is common. They both has a 90-degree angle C2 and angle A. Then from there, the third angle will become equal because angles in a triangle add up to 180 degrees. Now we have proved that the two triangles are similar to each other. We need a similarity sign here. Triangle DCO and the triangle DAB are similar to each other because they have equal angles. Now, if the two are similar to each other, it follows that their sides are in proportion. What it means is that if you take the first two letters divided by the first two letters, that will create the fraction DC divided by DA. Then if you take the second letter to the third letter and the second letter to the third letter, it creates CO divided by AB. Then if you take the outside one, D to O and D to B, you will create DO over DB. All these three fractions are equal to each other. Then you have a look at the expression we want to prove and the one that we are already given here. We notice that in this case, we may have to use dA times dO. And to multiply dA times dO, dA is in the first fraction and the dO is in the third fraction. So we're going to multiply the first fraction and the third fraction. dA times dO is equal to dC times dB. That is pretty much our answer. Now what we need to do is to just make sure that this expression here is exactly the same as the one that has been given. So from the information provided, the question says dA times dO, which is what I have here, dA times dO. It is equal to OD squared plus OD plus times OA. What it means is that in this space I can remove that expression dA plus dO and replace it with OD squared plus OD times OA because the two are the same. Then secondly, this part here, this is dB. From the diagram, the line from D right through until B. Now this is divided into two parts. We have BC being equal to CD, which means if you multiply CD by 2, you will get dB. So now it means we can remove this part, which is dB, and replace it with 2 times CD, because CD is half of the line BD. Then if we do that, our expression now becomes OD squared plus OD times OA is equal to DC multiplied by 2DC. Then DC times DC gives us DC squared. Now we have got our proof done and our answer is now complete. So when you're looking at the question, it will look difficult because of how long the expression is. But generally, this simply requires you to make sure that you organize the information. The hints are there that can tell you which theorems to apply in that particular question. And that will lead you to the answer with no problems. All right, guys, thank you very much. We meet later.